water-piped service ground is generally no longer required in most cases, given that the neutral is grounded at the meter. According to the National Electrical Code, or NEC, water pipes are permissible as grounding electrodes only if they meet specific criteria. Firstly, the pipe must be metallic. Secondly, it must maintain direct contact with the earth. Thirdly, it should not be coated with non-conductive materials. Furthermore, the NEC mandates that the neutral be grounded at the service entrance. This measure establishes a low impedance pathway for fault currents, ensuring that the voltage on the grounded conductor remains near 0 volts. When a water softener is installed and the plumbing undergoes alteration using PVC, the original water pipe service ground is effectively removed. PVC, being a non-conductive substance, cannot serve as a grounding pathway. Although the NEC might not mandate a water pipe service ground, its presence can introduce an extra margin of safety. In situations where the primary grounding system experiences a failure, the water pipe can still offer an alternative route for fault currents. Even though not mandated by code, it is prudent to incorporate a separate grounding conductor connected to a ground rod when modifications involving PVC are performed. This establishes a backup route for fault currents, thus augmenting safety protocols. In electrical systems, grounding plays a critical role in safety and proper functioning. It provides a path for fault currents to flow back to the source, allowing overcurrent protection devices like circuit breakers or fuses to trip and disconnect the power. This prevents electrical shock hazards and minimizes the risk of fire or equipment damage. The National Electrical Code, or NEC, sets the standards for safe electrical installations in the United States. It outlines the requirements for grounding and bonding to ensure that electrical systems are properly grounded and that all metal parts are bonded together to create a low impedance path for fault currents. Grounding electrodes are conductive objects that are buried in the earth and connected to the electrical system to provide a grounding path. Common types of grounded electrodes include ground rods, metal water pipes, and concrete encased electrodes, also known as E for grounds. Ground rods are typically made of copper or copper-clad steel and are driven into the ground to a depth of at least 8 feet or 2.4 meters. Metal water pipes can be used as grounding electrodes if they meet certain requirements, such as being in direct contact with the earth for at least 10 feet or 3 meters and not being coated with non-conductive materials. Concrete encased electrodes are made of bare copper conductor that is encased in concrete and buried in the earth. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault currents. This includes metal conduits, metal enclosures, metal water pipes, and other metal parts. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. The NEC requires that the neutral conductor be grounded at the service entrance. This is typically done by connecting the neutral conductor to a grounding electrode. Grounding the neutral conductor helps to stabilize the voltage and provides a path for fault currents to flow back to the source. When a water softener is installed and the plumbing is replumbed with PVC, the water pipe service ground is removed. PVC is a non-conductive material, so it does not provide a grounding path. This means that the electrical system may no longer be properly grounded. Although the NEC may not require a water pipe service ground, it can provide an additional layer of safety. If the grounding system fails for any reason, the water pipe can still provide a path for fault currents. For example, if the ground rod is corroded or damaged, it may no longer provide an effective grounding path. In this case, the water pipe can provide an alternate path for fault currents, helping to prevent electrical shock hazards. It is generally recommended to add a separate grounding conductor to the ground rod when replumbing with PVC. This provides a redundant path for fault currents and enhances safety. The grounding conductor should be sized according to the NEC and should be connected to the ground rod and the service panel. In addition to grounding, bonding is also important for electrical safety. All metal parts of the electrical system should be bonded together to create a low impedance path for fault current. This includes metal conduits, metal enclosures, metal water pipes, and other metal parts. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. It is important to follow these requirements to ensure that electrical systems are properly grounded and bonded and that electrical shock hazards are minimized. Grounding is a crucial aspect of electrical safety and involves connecting electrical systems and equipment to the earth. This connection provides a path for fault currents to flow, allowing overcurrent protection devices like circuit breakers to trip and disconnect the power, preventing electrical shock and fire hazards. Here's a more detailed explanation. Firstly, the purpose of grounding is safety. Grounding provides a low resistance path for fault currents to flow back to the source. This low resistance path allows overcurrent protection devices to quickly detect and interrupt the fault, preventing electrical shock and fire hazards. Secondly, grounding electrodes. Grounding electrodes are conductive objects that are buried in the earth and connected to the electrical system to provide a grounding path. Common types of grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. Thirdly, ground rods. Ground rods are typically made of copper or copper-clad steel and are driven into the ground to a depth of at least 8 feet or 2.4 meters. The NEC specifies the minimum size and type of ground rod that must be used. Fourthly, metal water pipes. Metal water pipes can be used as grounding electrodes if they meet certain requirements, such as being in direct contact with the earth for at least 10 feet or 3 meters and not being coated with non-conductive materials. The NEC also specifies the minimum size and type of metal water pipe that can be used as a grounding electrode. Fifthly, concrete encased electrodes. Concrete encased electrodes are made of bare copper conductor that is encased in concrete and buried in the earth. These electrodes are typically used in new construction and are considered to be very effective grounding electrodes. Sixthly, grounding conductor. The grounding conductor is the conductor that connects the electrical system to the grounding electrode. The NEC specifies the minimum size and type of grounding conductor that must be used. Seventhly, bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault currents. This includes metal conduits, metal enclosures, metal water pipes, and other metal parts. Eighthly, bonding jumpers. Bonding jumpers are used to connect metal parts that are not directly connected together. For example, a bonding jumper may be used to connect a metal conduit to a metal enclosure. Ninthly, equipment grounding conductor. The equipment grounding conductor is the conductor that connects the metal parts of equipment to the grounding system. The equipment grounding conductor provides a path for fault currents to flow back to the source, allowing overcurrent protection devices to trip and disconnect the power. And tenthly, ground fault circuit interrupters. Ground fault circuit interrupters, also known as GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in a circuit and will trip if they detect a ground fault. Grounding is a critical aspect of electrical safety. By providing a low resistance path for fault currents to flow, grounding helps to prevent electrical shock and fire hazards. The National Electrical Code, or NEC, sets the standards for safe electrical installations in the United States. It outlines the requirements for grounding and bonding to ensure that electrical systems are properly grounded. Always follow the NEC guidelines and consult with a qualified electrician to ensure electrical safety. Let's delve deeper into the nuances surrounding water pipe grounding, PVC replumbing, and the recommendations outlined in the NEC. Firstly, understanding the NEC requirements for water pipe grounding. The NEC permits the use of metal water pipes as grounding electrodes, but with specific stipulations. The water pipe must be metallic, ensuring its conductivity. Direct contact with the earth is essential, facilitating the flow of fault currents. Non-conductive coatings are prohibited, as they impede the grounding capability. Secondly, the role of neutral grounding at the service entrance. The NEC mandates that the neutral conductor be grounded at the service entrance. This grounding provides a low impedance path for fault currents, ensuring that the voltage in the grounded conductor remains close to 0 volts. Thirdly, the impact of PVC replumbing on grounding. When PVC is used to replumb water systems, the continuous metallic pathway to the earth is disrupted. PVC, being a non-conductive material, eliminates the water pipe's ability to serve as a grounding electrode. Fourthly, safety considerations beyond code requirements. Even when not strictly required by code, a water pipe ground can offer an additional layer of safety. In the event of a grounding system failure, the water pipe can act as a backup path for fault currents. Fifthly, the recommendation for a separate grounding conductor. To enhance safety, it is advisable to install a separate grounding conductor connected to a ground rod when PVC replumbing is performed. This provides a redundant grounding path, ensuring that fault currents have a reliable route to ground. Sixthly, ground rod installation best practices. Ground rod should be installed to a depth of at least 8 feet or 2.4 meters, as specified by the NEC. The grounding conductor should be securely connected to the ground rod and the service panel. Seventhly, bonding requirements for metal components. All metal parts of the electrical system, including conduits, enclosures, and water pipes, should be bonded together. Bonding ensures that all metal parts are at the same potential, minimizing the risk of electrical shock. Eighthly, the significance of low impedance grounding paths. Grounding paths must have lower impedance to effectively conduct fault currents. High impedance grounding paths can impede the flow of fault currents, increasing the risk of electrical shock and fire hazards. Ninthly, regular inspection and maintenance of grounding systems. Grounding systems should be regularly inspected and maintained to ensure their effectiveness. Ground rods and grounding conductors should be checked for corrosion and damage. Tenthly, consulting with qualified professionals. When dealing with electrical systems, it is essential to consult with qualified electricians and adhere to local codes and regulations. Electrical work can be dangerous and should only be performed by trained professionals. In summary, while the NEC may not always require a water pipe ground, its presence can enhance safety. When PVC replumbing is involved, it is recommended to install a separate grounding conductor connected to a ground rod. Grounding is a critical aspect of electrical safety, and it is essential to follow proper grounding practices to protect people and property. Let's dive deeper into the technical aspects of grounding and bonding, focusing on the NEC requirements and best practices. Firstly, understanding the NEC Article 250, which covers grounding and bonding. NEC Article 250 provides comprehensive requirements for grounding and bonding electrical systems. It covers topics such as grounding electrode systems, grounding conductors, bonding jumpers, and equipment grounding conductors. Secondly, grounding electrode systems. The NEC recognizes several types of grounding electrodes, including ground rods, metal water pipes, concrete encased electrodes, and ground rings. The choice of grounding electrode depends on the specific application and local soil conditions. Thirdly, grounding conductors. Grounding conductors are used to connect the electrical system to the grounding electrode. The NEC specifies the minimum size and type of grounding conductor that must be used. The size of the grounding conductor is based on the size of the service entrance conductors. Fourthly, bonding jumpers. Bonding jumpers are used to connect metal parts of the electrical system together. The NEC specifies the minimum size and type of bonding jumper that must be used. Bonding jumpers are typically made of copper or aluminum. Fifthly, equipment grounding conductors. Equipment grounding conductors, also known as EGC, are used to connect the metal parts of equipment to the grounding system. The EGC provides a path for fault currents to flow back to the source, allowing overcurrent protection devices to trip and disconnect the power. Sixthly, grounding impedance. Grounding impedance is the resistance to the flow of current through the grounding system. The NEC requires that grounding impedance be as low as possible to ensure that fault currents can flow quickly and safely. Seventhly, ground fault loop impedance. Ground fault loop impedance is the impedance of the path that a fault current will follow from the point of the fault back to the source. The NEC requires that ground fault loop impedance be low enough to allow overcurrent protection devices to trip quickly and safely. Eighthly, supplemental grounding. Supplemental grounding is the use of additional grounding electrodes to improve the effectiveness of the grounding system. Supplemental grounding may be required in areas with poor soil conditions or where there is a high risk of electrical shock. Ninthly, grounding and bonding in hazardous locations. The NEC has specific requirements for grounding and bonding in hazardous locations, such as areas where flammable materials are present. These requirements are designed to minimize the risk of explosion and fire. 10thly, grounding and bonding in healthcare facilities. The NEC has specific requirements for grounding and bonding in healthcare facilities to protect patients and staff from electrical shock. These requirements are designed to minimize the risk of leakage current and to ensure that equipment is properly grounded. Grounding and bonding are critical aspects of electrical safety. By following the NEC requirements and best practices, it is possible to create electrical systems that are safe and reliable. Always consult with a qualified electrician when working with electrical systems. Proper grounding and bonding are essential for safety and compliance. They help to prevent electrical shock, minimize fire hazards, and protect sensitive electronic equipment from damage. Always consult with a qualified electrician to ensure that your electrical system is properly grounded and bonded. Let's now discuss some specific scenarios and considerations related to water pipe grounding and PVC replumbing. Firstly, the case of existing homes with older grounding systems. In older homes, the water pipe may have been the primary grounding electrode. When replumbing with PVC, it's crucial to ensure that a suitable replacement grounding electrode is installed. Secondly, situations where the water pipe is the only available grounding electrode. In some situations, the water pipe may be the only available grounding electrode due to site constraints. In such cases, alternative grounding methods such as ground rods or concrete-encased electrodes may need to be considered. Thirdly, addressing concerns about stray currents on water pipes. Stray currents on water pipes can cause corrosion and other problems. Proper grounding and bonding can help to minimize stray currents and protect the water pipe from damage. Fourthly, dealing with mineral buildup and corrosion on water pipes. Mineral buildup and corrosion can reduce the effectiveness of water pipes as grounding electrodes. Regular inspection and maintenance can help to prevent these problems. Fifthly, considerations for homes with private wells. Homes with private wells may not have a continuous metallic water pipe system. In such cases, alternative grounding methods such as ground rods or concrete-encased electrodes should be used. Sixthly, requirements for grounding swimming pools and spas. The NEC has specific requirements for grounding swimming pools and spas to protect people from electrical shock. These requirements include the use of equipotential bonding and ground fault circuit interrupters. Seventhly, the importance of proper wire sizing for grounding conductors. Grounding conductors must be properly sized to carry fault currents safely. The NEC specifies the minimum size of grounding conductors based on the size of the service entrance conductors. Eighthly, using listed and labeled grounding equipment. When installing grounding systems, it's important to use listed and labeled equipment so that it meets industry standards. This ensures that the equipment is safe and reliable. Ninthly, documenting grounding system installations. It's important to document grounding system installations, including the type of grounding electrode, the size of the grounding conductors, and the location of grounding connections. This documentation can be helpful for future maintenance and troubleshooting. Tenthly, staying up to date with NEC changes and updates. The NEC is updated every 3 years, so it's important to stay up to date with the latest changes and updates. This ensures that your electrical system complies with the latest safety standards. By carefully considering these scenarios and considerations, it's possible to ensure that water pipe grounding and PVC replumbing are done safely and effectively. Always consult with a qualified electrician and follow the NEC guidelines to protect people and property from electrical hazards. Proper grounding and bonding are essential components of a safe electrical system. It's crucial to understand the NEC requirements and best practices to ensure that your electrical system is properly grounded and bonded. Consulting with a qualified electrician is always recommended for any electrical work.